All right, so today we're going to talk about global winds. They're a lot like local winds in that they always blow from high pressure areas to low pressure areas across the ground. That's what winds really, what we kind of like think about. So when we look at the Earth, if the Earth was smaller, okay, we would only have low pressure at the poles where the cold air is more dense and it's pushing down, and then warm air at the equator. Warm air would rise up, and then cold air would come down from the north, rise, and you would have one cell, one convection cell in the northern hemisphere and one in the southern hemisphere, and that would do it. The problem is the Earth is so large that we have some subcells that come down. So where the warmest section of the earth is along the equator, and that's going to be a constant area of low pressure because it's warm. Air will be rising there consistently. So if we have rising air here, we're going to have low pressure, just like with the land and the sea breeze. When the sand heated up during the day, it would be the air above it would rise, and you would have low pressure there, high pressure over the water. Well, the same thing here. The air is rising here. So as it rises, it's going to go north and south. But as it rises, it's going to get cooler. So as it gets cool, it reaches a point where it will start to fall, okay, which will be high pressure, which is about 30 degrees latitude. The air starts to fall. And when the air falls, it hits the ground, it'll go north and south. Same thing here. And then a little bit higher, up around 60 or 65 degrees, we have another low pressure area where the cold air coming down from the north gets warmed enough that it starts to rise again. Okay, so we get these different convection cells moving in here, which is pretty neat. So we have this basic circulation that we're going to get of these air cells where air's coming out, falling. You're going to get a cell that goes like this. Over here, with this low pressure, it's going to split north and south. We're going to get cells that are moving like this as we go down through here. Pretty cool. Now, the one thing that really complicates this is that the Earth is rotating. Because the Earth is rotating, it's going to curve the winds, or at least make it seem like the winds get curved. And that's called the Coriolis effect. Now, because the Earth is spinning as the air is moving up, okay, if air is moving up, the Earth is spinning underneath of it. We're moving past it. It looks like that it's curving, that the air is curving when the Earth is really just spinning around on it. So it looks as if the Earth, as the winds are being curved because the Earth spins as well. In the northern hemisphere, in the northern hemisphere, the winds always spin in a clockwise manner, which means in the direction that they're coming from, it's always going to turn to the right. So if you're moving this way, you're going to bend down. If you're moving downward, you're going to bend this way, coming around. And then if you're coming this way, you're going to bend up and around that way. So you're always moving in a clockwise motion. Whereas in the southern hemisphere, it goes in a counterclockwise way. Okay? It moves backwards from the northern hemisphere. And that's just because it's in the south. Now, that affects the winds because the winds come up here, right, at the equator. They come out, and as they come back down, as they go north and south, as they come back down here, they hit the ground, they split, and they go north and they go south from here. Now, if it's going south, okay, we can see in the northern hemisphere, which way is it going to go? It's going to go to this way. It's going to go from the east to the west. So all the winds coming down this way are going to go from the east towards the west. If you're going north, okay, you're going to be turned from the west towards the east. So up here where we are, we live in the United States, and we're about here in here. The United States is right in here. It's called the westerlies because they blow from the west to the east. So when you watch the news, you see that weather systems move from the west coast towards the east coast. Now we can see that if you're moving down, this is basically making a circle. You can see that this moves in like a circular pattern, just like this. In the southern hemisphere, it does the opposite. It curves the opposite way, this way. As it comes down. Oh, sorry. As it comes down here, it curves the opposite way, this way. It comes down that way. And then up here, this way. We can see that the way they go. So when we go through all the different types of weather belts, or wind belts, I'm sorry, the wind belts, we can see what's going on. Now the doldrums, if air is falling, winds are basically moving along the surface, but if winds are the air is dropping here, the winds are going to be calm. That's why it's called the doldrums. They're calm winds. There's not a whole lot going on there because it's descending air. It's not really blowing sideways as much, and it's kind of going out from there. So there's not a whole lot of wind in the doldrums, is one of the things. The next one, the next slide that was on there is the horse latitudes. Another one, this is where it's high pressure, where air is constantly going down. So when air is going down, you're not getting as much sideways movements. But when you're in between these, you're going to get into the different wind belts where the winds can blow you. If you have constant low pressure here, where air is always rising, you're always going to be getting clouds made, and it's always going to be raining. So along the equator is where most of the jungles are, where the Amazon jungle is, the African jungles, Southeast Asia jungles are all right along here because it's low pressure over all the time, rains a whole lot. At this latitude, at about 30 degrees, are where a lot of the world's deserts are, because this is high pressure, it does not rain as much, so you're going to get a lot of deserts in this area. It's a pretty cool thing when we look at it. So, when we look at the doldrums, air rises, horse latitude, air is going down. Now, we can look at the trade winds, which is in between the equator at 0 degrees and 30 degrees. They blow from east to west, okay? And this is how a lot of people came from Europe over to here. They would use the trade winds because they blow constantly in that general direction and move with it. So they would blow this way, and this is what they would use to get there. The horse latitudes at 30 degrees was a dead spot, okay? That's where you could lose wind and you could get stuck if you were on a sailing vessel back in the day. And if you got stuck in the horse latitudes and you weren't going anywhere, you start running out of water, the horses and other livestock went over the sides. They would get rid of them because horses and the livestock would drink a lot of the water. And you had to bring what fresh water you could on the trip. So if you got stuck, the animals went over. So that was the horse latitudes. Now, as the air comes down, like I said, it goes north and south. The Coriolis effect, the winds that go north, the air that goes north, is going to be curved to the right. And this basically takes weather systems from the west to the east. Now we can see things come up the coast, but you can see when they do come up, they always kind of turn out, or if they're coming down from Canada, they always swoop out this way. They always come out this way, or they move straight across. So that's where we see our weather. And they're called the prevailing westerlies. They blow in a constant direction off of here. And this is what dominates our weather. Up here in the poles, up here, we have another easterly wind because as the air is descending at the poles, it's going to curve that way. Okay, same thing here. It's going to curve that way as we go. Very neat. Now, one thing that we can actually see to illustrate this is that when there's a hurricane, okay, most hurricanes that threaten the eastern part of the United States start in Africa over here, closer to the equator. They move across the Atlantic Ocean this way. As they're drifting north, they eventually get into cross the horse latitudes and get into the westerlies, and then they curve out this way. So many hurricanes never reach shore. They get into the westerlies before they reach the United States. But if they get into Florida and things like that, you'll see them. They go right up the coast, or sometimes they'll go into the Gulf of Mexico. Once they get into the United States, they always get blown from west to east across the United States out to sea. So that's how we see it. And we've never had a hurricane cross the doldrums, like the equator, where the doldrums are. Hurricanes can come up to and approach it, but they never cross it. This is where the two hemispheres meet. It's really really cool. So these are our wind belts, and these are our general things. Now, any day within here, our local weather, we could have easterly winds or something like that that's going on easterly. But in general, over large distances, the winds are going to blow from west to east where we live. But locally, the winds can come from any direction on any day. But in general, weather systems and large air masses are going to move with these global winds. And as they cross these different latitudes, they can change directions and things like that. So hopefully you found this informative. I think it's kind of hard to like really just learn it from the slides or a book. So good luck filling out the accompanying worksheet, and I'll be talking to you tomorrow.